According to NFPA 79 section 14.2.3.2, the common side of a DC power supply shall be grounded. The conductors used to ground the common side shall have white or grey insulation marked with a blue stripe. In a 24 volts DC circuit, the positive side would typically use a blue conductor. The negative, or common, side would use a white conductor with a blue stripe. This is how the circuit conductor should be identified when the common side of the DC power supply is grounded. However, there is an exception. If you are grounding the common side of the DC power supply at a location other than the power supply itself, and the grounding conductors are run in raceways, then the conductors are to be identified with green or green with yellow stripe insulation in accordance with section 14.2.3.4. So to reiterate, under normal circumstances, when grounding the common side of the DC power supply at the supply itself, the positive side uses a blue conductor. The negative side uses a white conductor with a blue stripe. But if grounding remotely and running the grounding conductors in raceways, you must use a green or green with yellow stripe conductor for the grounding conductor. It is important to adhere to these color codes for safety and ease of troubleshooting. Correct conductor identification is crucial in electrical systems. Firstly, it helps ensure proper installation and wiring. Secondly, it aids in identifying the circuit during maintenance and troubleshooting. Thirdly, consistent color coding reduces the risk of electrical shock. This is because personnel can quickly identify which conductors are energized and which are grounded. Fourthly, adhering to NFPA 79 standards ensures compliance with industry best practices. Fifthly, following proper grounding procedures is essential for equipment protection. This prevents damage from electrical surges and faults. Sixthly, clear and consistent color coding improves overall system reliability. This reduces the likelihood of errors during installation and maintenance. Seventhly, utilizing the correct grounding conductors minimizes electromagnetic interference. Eighthly, maintaining proper grounding helps in achieving a stable and reliable electrical system. Ninthly, proper identification allows for quick isolation of faulty circuits. Tenthly, correct application of grounding methods improves the safety of personnel working on the system. Therefore, understanding the specific requirements of NFPA 79 regarding DC grounding and conductor color coding is of paramount importance. Remember, blue for the positive side, white with a blue stripe for the negative common side when grounded at the power supply, and green or green with yellow stripe for grounding conductors run in raceways when grounding remotely. Always consult the latest edition of NFPA 79 for the most up-to-date requirements and interpretations. This ensures that you are following the correct practices for your specific application. Proper grounding practices are not only essential for safety but also for ensuring the long-term reliability and efficient operation of your electrical systems. Also, remember to clearly label all conductors and terminal blocks. This further enhances safety and simplifies troubleshooting. The use of appropriate tools and equipment for conductor termination and grounding is equally important. This includes using correctly sized crimp connectors and torque wrenches to ensure proper connections. Regular inspections and testing of grounding systems are also recommended to verify their effectiveness. Use a ground resistance meter to measure the resistance of the grounding system. This can identify any potential issues before they become major problems. Furthermore, proper training for personnel working with DC electrical systems is essential. This includes training on grounding practices, conductor identification, and safety procedures. Also, be aware that other standards and regulations may apply depending on the specific application and location. Therefore, it is important to consult with qualified electrical professionals to ensure compliance with all applicable requirements. By following these best practices, you can ensure a safe, reliable, and efficient DC electrical system. Keep in mind that improper grounding can lead to a variety of problems. These problems include electrical shock hazards, equipment damage, and even fires. Therefore, it is crucial to pay close attention to grounding details and to follow all applicable codes and standards. Also, remember to document all grounding connections and test results. This provides a record of the grounding system's performance and can be helpful for future troubleshooting. The information you provided regarding conductor color coding aligns with common industry practices and the requirements of NFPA 729. It is important to stay informed about any updates or revisions to these standards. This is because electrical codes and standards are constantly evolving to address new technologies and safety concerns. Finally, always prioritize safety when working with electrical systems. If you are unsure about any aspect of grounding or conductor identification, consult with a qualified electrical professional. They can provide guidance and ensure that your system is installed and maintained in accordance with all applicable requirements. Also, remember that the specific requirements for grounding and conductor identification may vary depending on the type of equipment and the environment in which it is used. Therefore, it is important to consider all relevant factors when designing and installing electrical systems. Proper grounding is an integral part of any electrical system. By following best practices and adhering to applicable codes and standards, you can ensure a safe, reliable, and efficient system. And remember to always double-check your work and to verify that all connections are secure and properly terminated. This helps to prevent future problems and ensures the long-term performance of your electrical system. Furthermore, consider the impact of grounding on other electrical systems in the facility. Proper grounding can help to minimize interference and improve the overall performance of the electrical network. Also, be aware of the potential for ground loops and to take steps to prevent them. Ground loops can cause noise and interference in sensitive electronic equipment. Therefore, it is important to design the grounding system to minimize the risk of ground loops. In summary, grounding the common side of a DC power supply as per NFPA 729 requires careful attention to conductor color coding. Use white with a blue stripe, unless grounding remotely in raceways where green or green with yellow stripe is mandated. Always prioritize safety and consult the latest standards. Finally, remember that grounding is a critical aspect of electrical safety and system performance. Take the time to understand the requirements and to follow best practices. This helps to ensure a safe, reliable, and efficient electrical system. Proper grounding plays a crucial role in minimizing the risk of electrical hazards, protecting equipment from damage, and ensuring the reliable operation of electrical systems. Remember that periodic inspections and testing of grounding systems are essential to verify their continued effectiveness. Over time, grounding connections can become corroded or loose, which can compromise the integrity of the grounding system. Therefore, regular inspections and testing can help to identify and correct any potential problems before they become major safety hazards. Also, be sure to use appropriate personal protective equipment, PP, when working with electrical systems. This includes wearing safety glasses, gloves, and other protective gear as needed. Finally, never work on electrical systems unless you are properly trained and qualified. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to perform the work safely. Remember to always de-energize the circuit before working on it. This helps to prevent electrical shock and other hazards. Also, use a voltage tester to verify that the circuit is de-energized before beginning work. In addition to following the requirements of NFPA 729, it is also important to be aware of any other applicable codes and standards. These might include the National Electrical Code, NEC, or other local codes and regulations. The specific requirements may vary depending on the type of equipment and the location in which it is used. Therefore, it is important to consult with a qualified electrical professional to ensure that your system is installed and maintained in compliance with all applicable requirements. Lastly, remember that grounding is an ongoing process. It is not something that you can simply set and forget. It is important to regularly inspect and test the grounding system to ensure that it is functioning properly. This helps to prevent problems and to ensure the long-term safety and reliability of your electrical system. By following these guidelines, you can ensure that your DC electrical system is properly grounded and that it meets all applicable safety requirements.